All right, this is a study guide for Algebra 2, Unit 8, Exponential Functions. So starting at number 1, they ask, use the rules of exponents to evaluate or simplify, right, without negative exponents, all right? So they say 6 times 9 to the power of 0. So what we need to remember is anything to the power of 0 equals 1. So 9 to the power of 0 equals 1. 6 times 1 equals 6. The end. Number 2, same thing, the rule of exponents. So we don't want to deal with a negative exponent. This says 1 over 5 to the power of negative 2. So as soon as we see that negative exponent, we're going to invert it to the opposite side of the fraction, all right? So this would come up here, it would say times 5 to the power of 2. Well, 5 times 1 is 5. So 5 squared is your answer. 5 squared is 25. All right? Number 3, they throw in a little monkey wrench. They say 1 over 9 in parentheses, so both of them, to the power of negative 1/2. All right? So remember that a negative exponent is going to, number 1, invert both of them because they're both to a negative exponent. So then it's going to say 9 over 1, which is this 9, to the power of 1/2. An exponent of 1/2, when you have a fractional exponent, the top number is the power, and the numerator is the power, and the denominator is the root. Okay, so power of 1, root of 2. So the exponent 1/2 is actually means the square root of. So the square root of 9 equals 3. All right, and then number 4, this ABM in parentheses to the power of negative 2. So that means all 3 of them are to the power of negative, actually 3, not 2. All right, negative 3. So you just have to invert it. Right now it's in the numerator of the fraction. So you're just going to move all 3 A, B, M, and you might as well just leave them all in this parenthesis and say they're all to the power of 3. All right, continuing on with exponent rules. On problem number 5, they say y to the power of negative 5 over y to the power of negative 2. So if they have the same base as in y, it's in both, then you can combine your exponents. When your exponents are on opposite sides of fractions, you subtract to whatever side has the bigger number. In this case, negative 2 is bigger than negative 5. So you're going to subtract the y to the power of negative 5 on the bottom. So you're going to just have a 1 up there. It's going to say y to the power of negative 2 minus negative 5. Okay, and minus negative means positive. So negative 2 plus 5 actually equals 3. So your answer will be 1 over y to the power of 3. All right, number 6, they give us another fractional exponent. So remember, a fractional exponent, the top number is the numerator, and the bottom number, the numerator is the power, and the bottom number is the root. So this one's going to say 5th roots of negative 243 to the power of 3. So you can use your scientific calculator for this. You're going to say negative 243 to the power of 3, and then the root of 5. All right, number 7, we're going to deal with a fractional exponent again. Remember, it's 1/2. Fraction 1/2 is easiest. It just means the square root of. So, because it's the power of 1, the root of 2. So this just means the square root of 25, which equals 5. All right, then on number 8, they start taking us backwards. So they want you to look at the square root and tell us what the fractional exponent would be. So again, this is just the square root. So these are to the power of 1/2. Square root equals 1/2. So this is going to say AB to the power of 1/2. They may want you to put an A to the power of 1/2, B to the power of 1/2. I'm not exactly sure. Let me look. Yeah, just leave it in parentheses, I think, is what they'll want. Continuing with number 9, again, they want to simplify the expression using fractional exponents instead of radicals. Okay, so remember the power, the numerator is the power, and the denominator is the root. So in this case, x is going to be to the power of 2 over 8, and y is going to be to the power of 4 over 8. Now both of these can be reduced, so that's the simplifying part, all right? So this is going to be to the power of 1/4, and y is going to be the power of 1/2. So there it is, simplified. Number 10 is the same thing. They just want you to express it in simplified fractional exponent. So again, 2/8, which reduces to 1/4. All right, number 11, they say 5 divided by square roots of 5. So this one, I'm not sure where it came from, but we will do it. You can't have square roots in the denominator. So to rationalize this, you have to multiply it by itself. Because when you multiply a square root by itself, you get itself outside of square root. So you're going to multiply by square roots on top and bottom. So this will give you 5 square roots of 5 over square roots of 5 times square roots of 5 is 5. And then those 5s just cancel. So what you're left with is square roots of 5. Number 12, again, it's a radical. Remember, you're just going to work this problem. You're going to say 27 squared, so go 27 times 27, and then find the cube root of that. Again, you can use your scientific calculator. I didn't put numbers in. 13, you're solving for exponents. All right, because your unknown is in an exponential place. It's 2 to the power of x equals 256. So one way to solve this is to lower them to the same base. If they have the same base, then you can solve for the exponents. So I'm going to guess that 256 has a base of 2, and I believe it's 2 to the power of 8. Right? So now these bases are the same. We have 2 and 2. Those can cancel, and we can just look at the exponents. X equals 8. So 2 to the power of 8 equals 256. Same thing here, except for 8 isn't in lowest terms. 8 is 2 to the power of 3. So we're going to change that to 2 to the power of 3, x, and then 256 is 2 to the power of 8. So again, the bases cancel. We have 3x equals 8. So x is equal to 8 over 3. Number 15, they want you to express in a logarithmic form for the base. All right, so in these, what you do is solve for the exponent. All right, so your exponent is y. So that's going to go over here by itself. Y equals, and then log. So log is what you put when you move an exponent off the side. So it's opposite. And then the base goes right there, small behind it. And the base is what is raised to an exponent. And you put what your answer at the back. All right, and then so in 16, they just want you to do the opposite. So this one is already in logarithmic form, and they want you to put it in exponential form. So remember, what you're solved for is your exponent. This is your base. So your base is b to the power of y equals m. There it is in exponential function. All right, we're going to work with these logarithmic expressions here in 17, 18, and 19. So in is the opposite of e. So this is just like the logarithmic expressions we did. We've solved for the exponent, and this is our base. So we're going to say e to the power of x equals e. Well, e to the power of what equals e? Anything to the power of 1 equals itself. So we can know this is x equals 1. All right, same thing here. E is the base, x is the exponent, 1 is the answer. So e to the power of what equals 1? Well, anything to the power of 0 equals 1, right? So in this case, x equals 0. And same thing here. This is going to say e to the power of what equals square roots of e. So remember, the fraction 1/2 is the square root of. So as soon as we see x equals 1/2. All right, number 20, it says solve for log 28.9. You're just going to use your scientific calculator for that. Put 28.9 and hit the log button. Number 21, they want you to solve this logarithmic equation. Excuse me. So you're solving for x. So the first thing you can do is move the 6 and subtract it on the other side. So what you're left with is in, and then you can put your e right here because the opposite of in is e. X equals 2 because 8 minus 6 is 2. So again, you can just switch this to be put in exponential form, which would say e to the power of 2 equals x. Right? So you're going to use your scientific calculator to solve for this and you put in e to the power of 2. So to find e, you go to your scientific calculator and you hit inverse and then in because e is the inverse of in, and then put 2 and hit enter and you'll find your and they ask you to round to the nearest hundredth. Okay, number 22 is another logarithmic equation they want you to solve. It says 2 log 3 x plus 4 minus log 3 9 equals 2. Whew, a little bit confusing, huh? So number 1, I guess so remember if you're adding or is it subtracting, I'm sorry. Your exponents are going to, you can solve this one first, I'm sorry. This one, we're going to solve this with that. So this says 3 to the power of what is 9, right? So we're still going to have this log 3 right here, x plus 4. But then here we're just going to have a minus 2 because 3 to the power of 2 equals 9. So it just kind of cancels that one out real quick. Then we're going to move the 2 to the other side and it adds. All right, so it's going to say log 3 x plus 4 equals 4. All right. So now we're just going to write this in in exponential function. So remember, this is your base. 3 to the power of your exponent is here, equals x plus 4. All right, so 3 to the power of 4 would be 3 times 3 times 3 times 3. Do that and solve for x. So you'll just subtract 4 from whatever that answer is. All right, problem number 23 is a little bit simpler because they all have log 2 connected to them. So that means we can actually cancel all of those out and we just have to multiply. Remember, in an addition form, you multiply your two things, okay? So all of these can just disappear and you're gonna have x minus 6 times x minus 4 equals x. And you're just gonna solve this. All right, so we're going to do FOIL method here on this side. X times x is x squared. Outer is x times negative 4 is negative 4x. Inner negative 6 times x is negative 6x. And last, negative 6 times negative 4 is plus 24. We got to move this x over here now, so we're going to go minus x equals 0. All right, so we're going to solve for this. We're going to have a x squared, and then we have a negative 4x minus 6 is negative 10. Minus 1 more is negative 11x plus 24 equals 0. So now we have a quadratic and we can solve by our different forms we learned when we did our quadratic. So we could do factoring, completing the square, or quadratic formula. I really think factoring is going to be the simplest here because there's no coefficient on the first term, so automatically it's x and x, and then the factors of 24 that add or subtract to 11 are going to be 8 and 3. So you're going to say 8 and 3, and it's a negative positive, so they're both negative, equals 0. So it says x minus 8 equals 0, or x minus 3 equals 0. So x would equal 8, and x equals 3. But you have to put these both back in that original equation to see which ones are true. All right, so you're going to have to go in here and say, say we take 8. All right, so we're going to put, everywhere x is at, we're going to put 8. 8 minus 6 times 8 minus 4 equals 8. So this would see 8 minus 6 is 2. 8 minus 4 is 4 equals 8. 2 times 8 is 4. 2 times 4 is 8 equals 8. That's true. But we have to do the same thing with the 3. So you have to go 3 minus 6 is negative 3 times 3 minus 4. Let's see. 3 minus 6 times 3 minus 4 equals 3. 3 minus 6 is negative 3 times a negative 1 equals 3. 3 equals 3. All right, so it appears that one works as well. All right, number 24. Expressed in scientific notation. So they give you this number, 3.178, and they want you to, oh, did that totally wrong. 317.8. And they want you to express this in scientific notation. So in scientific notation, you want to put your decimal behind the first significant figure. This is a simpler way of writing a number with decimals. So you want to put your decimal behind the first significant figure, which would be 2 places to the left. Now, when you multiply this, if you're going to move your decimal to the right, so you write this, 3.178. If, to get the original number, you got to move your decimal to the right, you always multiply by 10, and then if you're moving to the right, your exponent is the number of times you moved, and if you're going to have to move it to the right, you want a positive number. All right, so this would be in the end, I want to move it 2 places to the right, so it's 10 to the power of 2. In problem number 25, it's a little bit backwards from that. It says 0.0273, right? And this time, I'm going to move my decimal 2 places to the left to start. So I want to put my decimal back here behind the 2, because that's the first significant figure. So this time, when I write this number to get the original number, I need to move 2 to the left. So that means my exponent needs to be a negative 2. All right, so you want a positive 2 if you're going to move your decimal to the right, and a negative if you want to move your decimal to the left. All right, problem number 26. They say use the equation to type the ordered pairs. So the equation is y equals 2 to the power of x. And then they give you all the x's. The first one is negative 1. So y would equal what if x was negative 1? So 2 to the power of negative 1. So remember, a negative exponent inverts the number. So y would equal 1/2. So when x is negative 1, y is 1/2. And you have to do this with all of them. So the next one would be 0. Y to the power of, y equals 2 to the power of 0. 2 to the power of 0 equals 1. So when x was 0, y is 1. And you're going to fill it out. And then problem number 27, you just have to put them on the graph, okay? Number 28, it's the same equation but backwards. They say instead of y equals 2 to the power of x, it's x equals 2 to the power of y. The equation they actually give you is the logarithmic form, so it says y equals log 2 to the 2x, like that. So this says 2 to the power of y equals x. So it's backwards, and then they give you x. So what is y? So this time, the first one they give you is 1/2. So x is 1/2. So 2 to the power of what equals 1/2? So what gives you a fraction? A negative exponent. So this actually, 2 to the power of y would be, this would say 2 to the power of negative 1. So y equals negative 1, because your exponents can cancel. So when x was 1/2, y is -1. All right? The next one, you're going to say 2 to the power of y equals, what's the next point? 1. So 2 to the power of what equals 1? Well, 2 to the power of 0 equals 1. Anything to the power of 0 equals 1. So your point was x is 0. When x is 1, y had to be 0. When x was 2, 2 to the power of what equals 2? Well, 2 to the power of 1 equals 2. So when it's 2, it equals 1. Fill that out, and then again in number 29, add it to the graph, those points you found. Number 30, they ask you to use the matrix method to solve, all right? So matrix method, this is the easiest way I've found, is to find the determinants. You're going to use this, you're going to find the system determinant, the x determinant, and the y determinant. So your problem is x plus 4y equals 8, and 2x plus y equals 9. All right, so you're finding two determinants. You're going to find the system determinant, the x determinant, and the y determinant. All right, for the system determinant, you take the coefficients on x and y. So you would take 1 and 4, 2 and 1. 1, 4, 2, 1. All right, to solve these, you multiply across and subtract. So this would say 1 times 1 minus 2 times 4. So 1 minus 8 is -7. -7 is a system determinant. The x determinant, you're going to take everything but x. Everything but the coefficient on x, and you're going to take it backwards. So instead of 4 and 8, you're going to say 8 and 4. So you're going to do the same thing here. 8 and 4, 9 and 1. Same thing here, 8 times 1 minus 9 times 4. 8 times 1 is 8, minus 36 gives you a -28. All right, and the y determinant, you take everything but y, everything but the coefficient on y, and do it forward. So you're going to say 1, 8, and 2, 9. 1, 8, 2, 9, and again, cross multiply. 9 times 1 minus 2 times 8. 9 times 1 is 9, minus 16 is a -7. All right, so to get x, what you do is you take the x determinant and divide it by the system determinant. So -28 divided by -7 is a +4. And to find the y, you take the y determinant and divide it by the system determinant. So the y determinant is -7 divided by -1 is -7, sorry, is a +1. So x and y are 4 and 1. Number 32, they just have you add two matrices on anything that has an addition or subtraction sign, or even a subtraction sign right in the middle. You just multiply straight, or add or subtract straight across. Makes it very simple. Just add. 8 plus 4 is 12, and 7 plus 2 is 9, and you're done with that one, okay? So look for these addition symbols. Don't make it harder than it is. But on problem number 33, this one is an simple. All right, this one, you have two 2x4s, all right? So when they say 2 by 2, the first number is the rows and the second number is the columns. All right, so rows go this way, columns stand up straight like a column in a building. All right, so to solve this, you're going to get a 2 by 2. I don't know why I keep saying 4 by 4. A 2 by 2. You're multiplying these. All right, so this one right here would be row 1, column 1. So this is actually called A11. Okay, this is row 2, column 1. All right, A21. This one is row 1, column 2, and this is row 2, column 2. All right, so if you're wondering what the 11s, 21s, and 22s are, row and column. So to get A11, you're going to use row 1 and column 1, okay? In this one, you're going to use row 1, and in this one, you're going to use column 1. So you're going to use 1/8 and 7/7. This is for the A11 spot. Okay? Same thing, you're going to multiply these two and multiply those two and add them. All right, so 1 times 7. So you're going to say 1 times 7, then 8 times 7. 1 times 7 is 7. 8 times 7 is 56. 56 plus 7 is 63. So that means A11 is 63. All right, for A12, you're going to use row 1 and column 2. Okay, so row 1 in the first box is 1/8. And column 2 is 6/4. Same thing here. You're going to go 1 times 6, 8 times 4. So 6 plus 32 is 38. So this would be 38. All right. For A21, you're going to use row 2 and column 1. So you're going to do the same thing, but with 0, 1, and 7, 7. So 0 times 7 is 0. 7 times 1 is 7. So 0 plus 7 is 7. That's not 1, that's a 7. My bad. There we go. All right, so it would be 0 times 7 is 0, and 7 times 7 is 49. 0 plus 49 is 49. All right, and for 22, you're going to use row 2, column 2. All right, so 0 times 6 and 7 times 4, and that will get it worked out for you. All right, do your very best on this test. It seems pretty simple. Know how to change from a logarithmic function to a exponential function. Remember your matrices method. That's probably the biggest problem on this test. All right, do your very best.